Coming up!
The most powerful aircraft carrier ever built is not sitting in a harbor.
It is cutting through open water right now, armed with weapons that have never been seen on any warship in history.
The U.S. Navy just loaded its brand new Ford-class carriers with systems so advanced they make every other warship in the world look like a relic.
And today, we are breaking down every single one of them, one by one.
The Gerald R. Ford-class aircraft carrier is not just a bigger version of what came before it. It is a completely different machine, built from the ground up with new technology, new weapons, and a new way of fighting wars at sea. Every major system on this ship was redesigned. The launch system, the landing system, the radar, the weapons, the power supply, all of it.
All new, all more lethal than anything that came before. And here is why this matters right now.
The world is getting more dangerous. China just launched its most advanced carrier. Threats to U.S. forces at sea are growing.
They responded by building the most powerful strike platform in naval history.
These carriers are out there right now, and the weapons on them are unlike anything the world has seen before.
Before we get into what these weapons actually are, drop a comment below and let us know, which one of these weapons do you think is the most important for keeping America's edge at sea?
We want to hear from you. The Navy's way of thinking about launching aircraft forever. Emails. The launch weapon. For more than 50 years, every U.S. Navy carrier launched its aircraft the same way.
Steam. A massive blast of compressed steam slammed against a piston, and that piston hurled the aircraft down the flight deck and into the air.
It worked. It had worked since World War II. But it was violent, it was heavy. It required enormous amounts of fresh water, and it could not handle certain types of aircraft at all. The Ford-class carriers replaced all of that with the electromagnetic aircraft launch system, EMALS. Instead of steam, EMALS uses a powerful electromagnetic pulse to accelerate the aircraft down the deck. The launch is smooth, controlled, precise. The amount of energy delivered can be dialed in for each aircraft type, from a heavy, fully loaded FA-18 Super Hornet,
all the way down to a lightweight reconnaissance drone. Why does that distinction matter?
because the old steam system was too rough and too sudden for lighter, unmanned aircraft.
It would essentially tear them apart. Emails eliminates that problem entirely. It means an entirely new class of unmanned aircraft. Drones that can scout, strike, and support manned fighters can now be launched from a U.S. carrier for the first time in history.
The performance numbers back this up. The USS Gerald R. Ford is designed to generate 160 sorties per day under normal operations. In a full combat surge, around-the-clock flight operations, that number climbs to 270 sorties.
Never come close to that number.
That is where the second weapon system comes in, and it is just as important. AAG, the recovery weapon.
Being carrier deck is one of the most dangerous things a pilot can do.
The aircraft comes in fast, slams down hard, and a wire catches the tailhook, stopping the plane in just a few hundred feet. The system that controls that wire has been hydraulic since World War II. It worked, but it applied the same stopping force to everything.
In heavy jets and light aircraft alike, there was no adjusting for what was coming in. The Ford class changed that. With the Advanced Arresting Gear, the AAG, instead of hydraulic pressure, the AAG uses water turbines that automatically adjust the stopping force for each specific aircraft. If a heavy fighter comes in loaded with fuel and weapons, the system responds with more resistance.
If a lightweight unmanned aircraft comes in after a mission, the system adjusts down.
Every single landing is handled with exactly the right amount of force. Nothing more, nothing less. This makes every recovery safer for pilots. It dramatically reduces physical stress on the aircraft's landing gear and airframe. And it means the carrier,
including unmanned systems that the old hydraulic equipment would have destroyed on contact. Here is the bigger picture. They were not designed just for today's aircraft, they were built specifically for the next generation of unmanned carrier aviation.
Drones that are already being developed and are getting closer to full deployment with every passing year.
Together, these two systems set the stage for everything else on this carrier. And the next weapon is already in the air.
Already proving it low in real-world scenarios. And it is something no adversary has a real answer to. The F-35C is the Navy's stealth carrier-based fighter.
And calling it a fighter jet undersells what it really is. It is a flying combat system.
A platform that carries weapons, collects intelligence, and shares targeting data across an entire strike group.
And coordinates strikes in real time. The F-35C carries its weapons inside the aircraft, in sealed internal bays.
Nothing hangs off the wings. That internal carriage eliminates the radar reflection caused by external weapons and fuel tanks.
From an enemy radar screen, the F-35C presents one of the smallest signatures of any aircraft in the sky. In many combat scenarios, it is effectively invisible at useful engagement range. Its unrefueled combat radius
is approximately 1,200 nautical miles, the distance it can fly, engage a target, and return without stopping for fuel.
With air-to-air refueling support, that range extends significantly further, putting virtually any target within reach.
But the most powerful thing about the F-35C is not what it does alone. It is what it allows the entire strike group to accomplish. The F-35C uses its advanced sensors to locate and identify.
It then shares that targeting data instantly over a secure network, with FA-18 Super Hornets flying safely behind it.
Those Super Hornets fire long-range missiles from beyond the range of enemy defenses. The F-35C never has to enter the kill zone.
It finds the target, marks it, and disappears. The Hornets do the rest. This kind of networked warfare, where one aircraft acts as the eyes and another acts as the fists, is something no adversary has developed a full counter to. And it runs through every F-35C that operates off a Ford-class carrier.
But the missile those Super Hornets are carrying? It has capabilities of its own that most people have never heard about.
Most anti-ship missiles fly a straight line. They are fast and powerful, but they go where they are aimed, and that is it.
The long-range anti-ship missile, LRASM, does not work that way. This missile has an artificial intelligence guidance system built into it. It can navigate around threats it encounters along its flight path.
It flies extremely low, almost at sea level, to stay underneath enemy radar coverage, as it closes in on its target and selects the most vulnerable point to hit. Not just the center of the ship, the specific location that will cause the most damage.
Its range is classified. But what is publicly known is that it far exceeds previous generation anti-ship missiles.
And it was specifically designed to defeat the most advanced naval air defense systems in the world, systems built for the sole purpose of shooting down incoming missiles like this one. Beyond carrier-based fighters. That means the Navy now has multiple independent launch options. From fighters off the carrier, from patrol aircraft operating far away, all using the same lethal round.
Combined with the F-35C as the targeting platform, the LRASM creates a kill chain that is extremely difficult to break. The target often does not know it is being tracked until the missile is already inside its defenses.
That is a serious tactical advantage, and it sits right on top of these carriers every time they deploy. Now, striking hard is one part of the equation, but staying protected, that is the other part. And the defensive systems on the Ford class are every bit as impressive. Dual-band radar and the defensive shield. The Ford-class carriers do not just hit hard, they see everything around them. The ship carries a dual-band radar system, DBR, that combines two different radar technologies into one integrated unit. The S-band side handles wide area search, scanning the X-band side handles precision tracking once a threat is identified. Together, they can detect, track, and target hundreds of aircraft and missiles at the same time, at ranges no older single system could achieve.
Because both radar bands are merged into a single compact array, the island superstructure on the Ford class,
Ship's radar cross-section.
making the carrier itself slightly harder to detect from long range. Every design choice on this ship was intentional.
The DBR feeds directly into the ship's self-defense system, which pulls data from every sensor on board and presents one unified tactical picture to the crew. No guesswork, no information gaps.
One complete view of every threat in the battle space, updated constantly, for threats that get through the outer defense.
The Ford class carries fast-reacting surface-to-air missiles. Behind those sits the Close-In Weapon System, CIWS, a radar-guided rotary
gun that fires 4,500 rounds per minute at any missile that penetrates the final defensive layer.
The combination creates a defensive wall that is layered, redundant, and extremely difficult to breach.
But here is what is coming next. A weapon that does not use any ammunition at all.
And the Ford class was built from day one to carry it. The USS Gerald R. Ford is powered by twin A1B nuclear reactors.
Those reactors generate more than 100 megawatts of electrical power, more than 3 times what a Nimitz-class carrier produces. The old Nimitz ships generated 4,160 volts of electricity. The Gerald R. Ford generates 13,800 volts.
That gap was engineered on purpose. Because the next generation of naval weapons, directed energy weapons,
Meaning laser systems, require enormous, sustained amounts of electrical.
The Ford class was designed with exactly the power output those systems will need. Senior Navy officials have confirmed
that directed energy weapons are being actively developed for future deployment on carriers. The Ford class already has the power.
It has the physical space, because removing all those old steam generation systems freed up significant room inside the ship.
and the infrastructure to integrate laser weapons into the ship's systems is already accounted for in the design. When laser weapons come online on these carriers, the cost per engagement drops to nearly nothing. The magazine is essentially unlimited as long as the reactors are running, and a laser reaches its target at the speed of light.
Meaning no incoming missile, no matter how fast or maneuverable, can outrun it. The Ford class is already waiting for that technology.
It does not need to be retrofitted. The ship is ready. The last piece of this picture is unmanned aviation.
The MQ-25A Stingray is the Navy's first carrier-based drone, designed to operate directly from the flight deck.
Its initial mission is aerial refueling, extending the range of carrier-based fighters during long operations.
But it is also being looked at as a future strike platform, as the technology matures.
Initial flight tests for the Stingray were scheduled for early 2026, with an initial operational capability target of 2027.
When it reaches the fleet, it will extend the combat range of the F-35C and FA-18 significantly.
Reduce pilot exposure during non-combat missions, and open the door to an entire era of carrier-based unmanned aviation.
AAG can recover it. The power grid supports it.
Every system on the Ford class connects to every other. That is what makes this ship genuinely different from anything that came before.
It is not just a collection of upgraded parts. It is a fully integrated combat platform designed to evolve with new technology
over its entire service life. And that fleet is growing. The USS John F. Kennedy, CVN-79,
is on track for commissioning in 2027. The USS Enterprise, CVN-80,
follows with a planned commissioning in 2029. CVN-81, CVN-82, and CVN-83 are behind them.
The Navy's plan calls for a total of 10 Ford-class carriers, replacing every Nimitz-class ship one for one.
Each of those ships will carry every weapon we walk through today.
and every one of them will be ready for the laser systems and autonomous aircraft of the near future.
But it is not nuclear-powered. It cannot generate the electricity needed to support laser weapons.
And it does not have the decades of operational experience that U.S. carrier strike groups have built through real deployments around the world.
The U.S. Navy is not just holding its lead, it is extending it. The most powerful weapons ever placed on an aircraft carrier.
Are already out there, right now, sailing under the American flag. More of them are on the way.
And the technology being developed today will make these ships even more lethal in the years ahead. This is not a future plan, it is happening right now.